Yo, everybody, what's up? Today we have Michael Levan, consultant, trainer, and content creator joining us for our topic of Kubernetes. Yes, we're still talking Kubernetes. Is it just another virtualization of my virtualized data center that might be virtualized in somebody else's computer? I'm not sure, but what's the value? What's the skills? What about the cost of implementing it? Is it the latest fad or is Kubernetes here to stay? Please join me in welcoming Michael Levant to the show. Michael, buddy, thanks for joining me.
Thanks, John, for having me. Appreciate it.
Okay, Michael, we're going to jump right in it. There is this hot topic of Kubernetes, and it's getting bigger and bigger due to the recent, obviously, cost efficiency, optimization, and cloud optimization that's happening in the world today. Let's talk Kubernetes.
Yeah. So, to answer your question, is it virtualization on virtualization? I would say yes. You can have instances where you're running bare metal. You can have instances where you're running on VMs. You could have Kubernetes running in on your ESXi boxes. You could have Kubernetes running in the cloud. Obviously, there's a bunch of different places to run it. But from a virtualization perspective, this is the key difference to think about. ESXi, Hyper-V, Proxmox is it? All these virtualization platforms, right? These are to virtualize your hardware. Containerization is to virtualize your operating system. So it's still virtualization happening. It's just happening at a different level or layer, rather.
Now, wait. Because ESXi, so VMware, I'm virtualizing my hardware. ESXi is virtualizing the hardware, but I'm installing virtual operating systems, right?
Yep. Yeah, exactly. Yeah. So the whole idea about just like overall virtualization, like thinking about ESXi, thinking about Hyper-V, you take a server and this server maybe has, 64 gigs of RAM, X amount of cores, storage, yada, yada. So what would happen back in the day was you would buy this server and you would run one application on it, one application stack on it, and you would use like 20% of it. So like it didn't make sense because you were spending a ton of money. You were running these things in the data center. You had your HVAC systems on to make sure everything was cool. A lot of electric, just a lot of money going in and out in general, and a lot of boxes to manage for kind of no reason. So that's where virtualization came into play, where it was like, hey, this box, we're only utilizing 20% of it. Let's utilize all of it. Let's utilize 100% of it. But at the same time, we need to segregate these resources. That's where virtualization kind of came into play. Then thinking about containerization, now we don't care where it's running. We're just literally virtualizing the operating system and kind of, I don't want to call it watering down the operating system, but essentially just installing the necessary things. Like when you're running an Nginx container, when you're running, I think they would be considered nodes, like Bottle Rocket, for example, in AWS. Bottle Rocket is a Linux AMI. Sorry. That AMI, that container that's running Nginx, it only has on it what it needs to run. So that's the virtualization piece of, thinking about it from an operating system perspective. And obviously a smaller footprint. When you install any operating system, you're talking about gigs. When you install or run a container, you're talking about megs or less.
Why don't the operating systems run at megs and why are they running at gigs? Why can't I just have the necessary stuff? It's the dumbest question I have to ask, because if you think about it, I would buy even a desktop, right? Or a server, and my root volume used to have to be like, I don't know, a small amount, 10 gigs. Now my root volume for like a Windows server or operator has to be like 60 gigs because of the growth expanding. Why can't I have just run what I need to get what I need to get done?
Yeah. So, I think it really just comes down to bloat. When you're thinking about desktops in general, like when you're thinking about a Windows desktop, for example, if you look and see what's installed, like there's Xbox stuff installed, there's photo stuff installed,
Microsoft Store.
There's this, there's that. And that's fine for like the average consumer. but that's not fine for the business. Like I would certainly hope, unless it's just a really slow week, you're not sitting and playing Xbox games on your work computer. They probably can't run anyways.
Shh, you got me.
And then, when you're thinking about like Windows Server, same thing. There's so many, like when you're thinking about like Active Directory, when you're thinking about various different roles and features, print servers, SMB, etc. On a Windows server, there are so many different roles and features that you can install within the server manager that just causes it to grow and grow and grow. Then there is, from a Linux perspective, Linux, the distributions themselves are obviously way smaller. Like you could run Ubuntu on a 10 gig hard drive, but that 10 gig comes from just years of kernel updates and modularizations and everything, right? Like everything's kind of there since the beginning. And that's where, things like Bottle Rocket and stuff come into play. It's a Linux distro, but it's meant specifically to run containers. That's all it does. It does not do anything else. There's nothing else on it. So you do have these various levels of virtualization and operating systems where like you can shorten the footprint a little bit and you can make it a little bit smaller. You can water it down, whatever you want to call it, but it all kind of depends on where and how you're running.
Michael, Kubernetes has been around for some time now, quite often. I don't even know how many years. What are we, over 5 years now, or somewhere close?
Yeah, since around end of 2015.
Okay, so actually 8 years, but I still feel that it's not widely adopted. It's only really kind of picked up in the last couple of years, but I'm not
Mhm.
very familiar of many enterprises that have implemented it company wide. They might have implemented it for their development, but are they using it for production? And like why is it not picking up more in enterprise or production level?
Yeah, so I think it's very important to remember, and it's because we're all on social media, so like we kind of see this every day. Sorry to everybody that's listening, but I have to say it. There's a big difference between what technical marketers are telling us and what is actually happening in production environments. So for me as an independent consultant, I do things a little bit differently. Typically, you'll see independent folks, right, either just doing a bunch of content or doing a bunch of consulting. I do both. So I have clients where I'm working in their production environments. I'm writing production level code. I'm spinning up production level Kubernetes environments. And I'm also working with the product companies, writing blogs for them, doing videos, white papers, et cetera, et cetera. So I see both very, very well in real time. And what I can tell you is this: the products that are being created for Kubernetes right now, they're going to be more relevant in a couple of years. Kubernetes itself, it's going to continue to expand. And the reason why is because what happens in real enterprise production level environments is very different than what we're hearing on social media. This is the new thing. This is what's going to be working, et cetera, et cetera. The reality is that it takes enterprises a very long time to move off of what they're already running on. There are so many organizations that still have their own data centers, that still have fleets of ESXi boxes, and they're running perfectly fine. And they probably still have plenty warranty left. They probably still have plenty customer or engineering support from VMware left. Everything's running as is. So to get the enterprise to completely not only shift the way that they think, but have the engineering capacity, the people to migrate all of this stuff from VMware, put it on a container. That's just step one. And then get it into your orchestration platform, whether that's Kubernetes, whether it's Nomad, whether it's whatever it is. It's a very big lift, especially if you're an organization that's been around for 10, 15, 20 years. You got a lot of stuff. Quite frankly, you also probably got a lot of tech debt, which is most likely going to stop you as well. There's a lot of manual processes that are occurring. You don't know what those are. There's one person in the whole organization that knows what they are. It's, there. So it's not that Kubernetes isn't picking up steam. It's not that Kubernetes isn't being utilized. It's that to move from one architecture to another is not an easy thing. Now, with that being said, I do work from a consulting capacity. I do work with a lot of small organizations and a lot of startups to get, their environments up and running. And luckily with startups, they're starting fresh. So they get to start on all this stuff. But here's the thing. If those startups succeed and they exist in 10, 15 years, when the next new thing is out, they're going to have the same problem. Everybody's going to have the same problem over and over again. It's excuse me, it's just kind of, where we are.
Okay, there was a lot to unpack. The first thing is to mention is that it's taken enterprises, 5, 6 years to maybe go to Kubernetes, and that's the same thing with cloud, right? So cloud's big. There's only, I think it was labeled as maybe three. We might be up to 5% of companies are actually moved or migrated to cloud because it takes that amount of time. I think going to Kubernetes will, I don't want to say complicated, but will kind of revamp that decision making process and how they plan to go to cloud. Do we
Mm-hmm.
go to Kubernetes first and then in the cloud, or do we re architect it? And those are some of the questions I want to dive into in a second. Let's talk about Kubernetes specifically and some of the components. And then my next question off of that is it real? I mean, like, how do I repackage, redo an application to make it to Kubernetes? I mean, it's great in theory to do, but I need the skills. So what are the components of Kubernetes, and what's sort of the process that I can get an application packaged into it?
Yeah. So, I always see stuff online that everybody kind of talks about and says, Kubernetes makes things easier and yada, yada. And yes, that's true after you're in Kubernetes. But to lead up to get your workloads into Kubernetes is not a task for the faint of heart, right? Like it's not like something that you're just going to do. And, because again, going back to the technical marketing versus reality, and I hate to say it like that, but it's kind of true. How can I put it? I'm trying to think of the best way. The tools and the process and the procedures to make it easier, to get it going, to get it migrated, to move from a binary Java binaries or whatever binaries running on a VM or a bunch of VMs to get them containerized to put them into Kubernetes. There are tools and there are procedures and there are best practices, a million of them out there. But again, it's really a matter of hiring the people, getting the right expertise, getting your current staff trained up to understand that, because you're literally turning an orange into an apple. This isn't something where it's like, hey, let me just, take my binary and throw into a container and throw it into Kubernetes and poof, everything's done. It doesn't work that way. There are dependencies, there are several binaries, is your application a microservice stack or does it have dependencies? There's, okay, this part of the application needs to run, but to do so, middleware needs to be there. And that means the middleware piece needs to be containerized prior, but oh wait, there's also a database that it needs to talk to. And yeah, there's so many different things that you kind of need to think about. And not only that, but there is I'll call it the day zero piece, which is planning what you're doing. Where are you running Kubernetes? What security practices do you need for your organization, for your level of compliance? A startup creating a product is going to have way different compliance and security needs than a government regulated environment. So like there are all these different things, the different tools that you're going to use. There are over 1,300 tools on the CNCF landscape. You're not using all of them. You're not going to know all of them. You're maybe going to be an expert in 2 of them, if that. So you got to kind of figure out this whole process, like the whole planning process. And then you can start thinking about like, oh, now I need to containerize this application. Well, now I know I'm going to use Docker or cloud native build packs or Scaffold or whatever I'm using to create container images. So it's like, and I'm just talking and talking and talking, right? I'm kind of babbling, but the reason why I'm doing that is because I want to make it 100% clear that there are a lot of steps that you need to take. And usually organizations aren't going to have 30 free engineers to get all this stuff done. So you got to plan accordingly, because if you don't plan properly in the beginning, you will end up with a massive amount of tech debt later on. And, there's also the piece, and then I'll shut up, but there's also the piece of I can take a nail and I can hammer it into wood with, the handle part, but even though I can do it, it's not efficient, right? So like there are a lot of environments right now that are running Kubernetes that are not running them in the most efficient way. And when I say most efficient way, I mean the proper procedures and protocols and best practices. And hey, you can run it this way, but everybody's running it like this. So guess what? There's going to be far more documentation, support, community over here versus over here. Over here is homegrown. Over here is the enterprise. So there's just so many different things to think about when you're even debating the idea of utilizing Kubernetes.
Part of the components of Kubernetes, so Kubernetes is just the orchestrator for your containers, correct?
Yep.
And,
Yep.
and everybody says Kubernetes, can I really run, like, I can run a single container and run an environment, but it's not really efficient, right? For like development's okay, but for production, it doesn't do anything. If something breaks, something happens, it's done. My container, my node doesn't handle it. I mean, talk to me about the different components of containers and how Kubernetes is managing them and why I would take this into a production environment.
Yep. So by default, containers are meant to be looked at as ephemeral. So you should not be thinking about containers as long running. Containers inside of pods. Do pods run for a month, 2 months, 6 months? Absolutely, they do. Should you architect your design decisions about or around the idea of this thing is going to always run? No, because pods, containers, they're all meant to be ephemeral. So to your point, once a container goes down, like let's say I'm just running a Docker container on a server. If that thing has any issues at all, if it goes down, that's it. I have to manually go back in and rerun this thing. That's that's time consuming. That's cumbersome. Nobody wants to do that.
That
So
sounds like
that
the old school VMware and virtualized environment where it didn't have an auto restart feature. Right? I had to wake up my server admin at 2 a.m. to go power on the device.
exactly. Yeah, no, it's the same exact thing, 100%. And that's where orchestration platforms come into play. Whether you're using Docker Swarm, whether you're using Kubernetes, whether you're using Nomad, whether you're using ECS, whatever you're using, Azure Container Apps, GKE, GCP's, what is it? Cloud Run, I think. I think that's what it is. Regardless of what you're using, regardless of what orchestrator you're using, it does a lot of stuff. Don't get me wrong, but it has one job: schedule my containers, schedule my pods, make sure these things are running as they are supposed to be. Make sure that the current state is the desired state. Is the current state not the desired state? Make it the desired state. That's really the whole job of an orchestrator. An orchestrator, at the end of the day, like just thinking about Kubernetes, it has a scheduler piece in its control plane. That's really its whole job. Its whole job is really to take containers or pods in the Kubernetes sense and run them and make sure that they're running appropriately with what they need to be able to run and where they need to run and all that stuff. But then you have different pieces of it. So for example, on the control plane, again, you got the API server. Why do you have the API server? Well, because you need a way to interact with Kubernetes. Why do you have etcd, which is the data store, the database? Because you need a place to store all the information. Kubernetes has stuff that needs to be saved, so you need to save it all there. So it's there, and then you go into this and you go into that, and before you know it, you got this whole environment and this whole I'll call it infrastructure. But at the end of the day, when you peel back the onion, the whole idea of a orchestrator is scheduling pods and scheduling containers. And that's why, for example, I'll still never, well, I mean, I do understand it. It's just because this is just the way that the market went, but I'll never fully understand from a technical perspective why Docker Swarm didn't kick off way more than Kubernetes did. Docker Swarm is immensely easier to use than Kubernetes is. I mean, it's a night and day difference. It's so much easier to use Swarm. But here's the problem. There's no GitOps. There's no this tool. There's no that tool. People aren't building for Swarm. People aren't building right now for Nomad. So when we think about why we're using Kubernetes, really the reason why we're using Kubernetes is because that's what everybody's building for. And that's been the way that tech has been since the beginning of time. You look at ESXi versus Hyper-V, they're the same thing. Peel back the onion, it's the same thing. But everybody was building for VMware. And because of
I think
that,
it was
VMware
the
won the war.
names, the marketing value that you had, VMware versus Hyper-V, right? Or Kubernetes versus Docker Swarm. Kubernetes sounds cooler. I want to build for that, right? In all honesty, it was the visibility of the marketing and the capability out there that
Mhm.
probably kind of pushed some of that. Michael, let's talk a little bit about not only one of the things that the adoption and production. And here's my personal opinion. In my humble opinion, I must state, it is my disclaimer, that things that engineers are now doing, they play around with Kubernetes. This is really cool. I like this. Great. We're going to use it in production. It's the typical dev moves to production type model, which you really shouldn't do. But one of the things that you talked about before was that they're not building to best practices. So I played around with this in dev. It works. It great. It's run. Now I push it to production and not ending it to best practices. Does that go along the skill sets and some of the things that you're working with and doing as a consultant?
Yeah. So here's the thing. You mentioned this earlier that Kubernetes is about 8 years old, give or take. Now, if we think about the old psychology thought process of it takes 10,000 hours or 10 years to master something, nobody is a master. Nobody's an expert in the Kubernetes realm right now. Not to mention, Kubernetes is constantly changing. Not the core of Kubernetes, but how you're utilizing Kubernetes, the tools and the platforms and the add-ons that are being used for Kubernetes, the different practices. So at the end of the day, in my opinion, I think it's going to be incredibly hard to become an expert in Kubernetes. With that being said, the reason why Kubernetes is being implemented into these environments without best practices is because here's the thing. You take a platform engineer, you take a DevOps engineer, SRE, whatever you want to call it. Yeah, they got to worry about Kubernetes and containerization. They also got to worry about the 50 other things that they're working on. They got to worry about the network. They have to worry about CI/CD. They have to worry about infrastructure as code. They have to worry about their automation and their scripts. They don't have the time to sit there and just be an expert or be looked at as the expert in-house in Kubernetes. Because of that, that's where, like you said, I kind of come in from a consulting perspective because this is what I do. I just focus on Kubernetes and containerization. It's what I do day in and day out. So, it's very difficult to be an expert in something that's constantly changing. Now, with that being said, like I said, I focus on this 100%. I focus on Kubernetes and containerization 100%. I'm not an expert. I'm
I was
always
just
reading.
about to ask. So, Michael, aren't you an expert in this field?
I mean, because I don't think anybody can be. I am constantly always learning. I am constantly always testing and playing with new tools. I'm constantly always doing implementations. Just the other day, for example, I was working with one of my clients, and I could not, for the life of me, get EKS registered in Datadog. I've done it a ton of times with AKS. I've done it a ton of times with on-prem environments. I could not get EKS working. Now, for whatever reason, with the Helm chart, when you're deploying the Datadog cluster agent and node agents to your EKS environment, you have to specify in the Helm chart the cluster name. For whatever reason, you don't have to do that anywhere else, but you gotta specify it. And the Datadog documentation, nowhere in the documentation, like with the errors that I was getting, state, hey, this is what you need to do. So like this was literally just me. I had the Helm chart, the values.yaml is like 300 lines, I think, or more. And I'm just sitting there reading through it. And I'm like, what could the problem be? Because it's supposedly everything is good. And I just started throwing random values in. And I was like, oh, this is the one. Awesome. So like point being, I do the Kubernetes and the containerization every day. And like, I'm still like, things are still tripping me up. So I don't think that there's a way to be an expert in 100%. What I do believe is that if you have the ability to focus in 100%, go for it. That's what I'm doing. I enjoy it. I learn a lot. I play around with really cool technology. So that's my take on it.
So everybody, real quick, I just want to give you a recap on what we're talking about and who we're talking with. We're talking with Michael Levan, who's a consultant, trainer, and content creator. And our today's topic is around Kubernetes. What is it? Another virtualization of my data center that's virtualized in somebody else's data center? The skill sets, the cost of implementation, plus Is Kubernetes here to stay? Michael, you were talking about the Helm chart. What is the Helm chart? What is it used for?
Yeah, good question. So Helm chart is well, you can look at it in two ways. It's used to make your life easier, or you're going to hate your life after you use them. It's one or two. It's
It's
one
like
of the
flip a
two.
coin.
It's one of the two. So the idea of a Helm chart is this: when let's say you're deploying an application stack, you're going to have a ton of Kubernetes manifests for your front end, for your middleware, for your back end, for just all these pieces, for your secrets, for your config maps, just for your RBAC, just all these different various levels. So let's say by the time you're done, you got 15 Kubernetes manifests. Now you could run kubectl apply minus f and all of them, or you could use something like a Helm chart. So what a Helm chart does is essentially at a high level, it just takes all of your Kubernetes manifests and it just puts them into a package so you can deploy them all at the same time.
Is that like zipping them all up? Is that just like a zip file? I'm going to compress this and here you go.
No, not necessarily compressed, but it can be looked at the same way. So, like for example, if you and usually people have used Helm charts in one way or another. So, like I use them a lot, for example, to like install various tools like Datadog or Prometheus or Grafana or HashiCorp Vault or like whatever. And I just have to run one command: Helm install, point to the repo where the Helm chart is, and poof, I'm off to the races. But if you go into GitHub and if you look at the repo that Helm chart is pointing to, or the Helm install rather is what chart it's pointing to, you're going to see a whole bunch of files in there. You're going to see a whole bunch of templates, deployment templates, service templates, RBAC templates, CRDs, yada yada. So it kind of just takes everything that's in one place and deploys it all at the same time versus you having to manually run, excuse me, sorry, kubectl apply minus f, kubectl create minus f, etc.
Okay. Wasn't Kubernetes once thought of, oh, this is going to be awesome. It's going to make me cloud agnostic, hardware agnostic, the portability. I'm going to be able to take it from Azure to AWS to GCP, and it's not even going to matter. Is it still thought that way? And is it really possible?
Yeah, so the whole idea of Kubernetes in the beginning was just to schedule your containers. That was it. Like that was the whole purpose. It wasn't meant to be what it is today with all of these different third-party tools, with all these different services, with all this GitOps and this service mesh and this yada yada. It makes things easier in certain capacity, but at the but at the end of the day, like this was not what it was meant to do. Like I started using Kubernetes in 2016, 2017, and like this was not what it was meant to do. It was just meant to take my containers and manage them. That was it. But now it's all of this stuff, and because of all of this stuff, does it make certain things easier? Sure. Does it make everything harder? Absolutely. Like for example, like thinking about service mesh. The whole idea of service mesh, just at a high level, you have the ability to encrypt your traffic from a networking perspective because networks are usually very flat. So you're doing a lot of security for inbound and outbound, right? Egress, ingress, a lot of firewall rules, a lot of this thing can talk to that thing, etc. But once it's in the network, it's very flat. There's not a whole lot going on. Service mesh is pretty much allows you to manage that internal flat network, make sure that everything is encrypted, make sure east-west traffic is happening as expected, latency, making sure that you can troubleshoot all that, etc. That's just a high level of a service mesh. But can I do all of that without a service mesh? Absolutely. Like service mesh isn't inventing anything here. It's really just taking a whole bunch of stuff and packaging it up into one thing. So utilizing a service mesh, yeah, it makes all of that stuff way easier. But guess what? Now you got to go learn service mesh and you got to dive into Linkerd and Istio and Console Connect and yada yada. Like, so it does make things easier, but at the same time, it makes things harder.
You ever, there's this old movie, and I don't know if I can date myself back there. It's probably like 20 years old by now. I want to say a military comedy movie. And it was about creating a Bradbury tank. And this Bradbury tank was to go in and basically take forces either to the front or pull forces back. Simple design, right? That's all it was meant to do. Then they had the bright idea, like, oh, wouldn't it be nice to protect our troops? So they started putting on like extra weapons and everything on it. To, oh, wouldn't it be nice to, if it could float, it could drive across water? Yeah. So they started doing this. Now all of a sudden they added all these components from what it originally stated, and it was bloated. Does it feel like Kubernetes is, it was just a scheduler? Now it's throwing all these extra things, just like an operating system. I could have the minimal, but now I have all these extra things. Is it getting too much add-ons to it? And can I just simplify it to do what it was meant to be?
Yeah, so I believe that everything is done with good intention. Like for example, let's look at WordPress. What was WordPress supposed to be in the beginning? Blogging. Now it's like a content manager and these ads and this and yada yada. Like, so WordPress is very bloated right now. WordPress is
Oh, the
not
plugins for that.
everything.
Slow
Yeah,
down my website like crazy.
exactly. So like WordPress is not used today what it was intended for, however many years ago. Was it done on purpose? Was like somebody sitting there and they were like, we're going to make this thing suck. No, nobody was like, nobody thought that in their head. They were like, we want to add this thing. A customer is asking for this feature. Oh, this would be awesome. This would make things so much easier. And before you know it, you kind of just keep stacking until you're like, uh-oh, what is this behemoth that we just built? And I think Kubernetes is the same thing. Like, nobody's building these tools and platforms and stuff to be like, let's slow this thing down and make everybody's lives more difficult. People are building it because it's like, let's make things easier. And these things do make things easier. But then you take a step back and you're like, oh, there's a lot of stuff here. Like, there's a lot of stuff that you got to learn. There's a lot of stuff that we got to figure out. So it's, can you use Kubernetes for what it was just intended to do? Yes. Would you benefit from it? Not as much. Let's take a very strong yet simple example. Kubernetes secrets. You can use Kubernetes secrets, but here's the problem. They are stored in plain text, base 64, within etcd. So they're not actually secrets. They're not fully encrypted end to end. Because of that, you typically want to use a third-party secrets manager like HashiCorp Vault is a very good implementation in Kubernetes. So you're utilizing this thing outside of Kubernetes, but at the same time, it's making your life better. It's making you more secure, but at the same time, it's making it harder because now you have something else you have to manage. And so here's my take on it. Use what you need. Don't just go into the CNCF landscape and be like, all these 1,300 tools look great. Let's just deploy them all. Don't do that. Just use what you need and walk away from everything else. And I think that's very difficult for a lot of engineers, because like we kind of just look at stuff and we're like, ooh, shiny, this looks great. I do it all the time, literally every single day. I do it every
Squirrel.
day.
That's what I do.
Exactly. But like, then I got to take a step back and I got to be like, is this actually necessary? No? All right, let's walk away from it. Really cool. Only use what's necessary. Exactly. and that's, going back to what I was saying before, that's the day zero piece. That's the planning piece. That's the, what does this thing need? And that's it. Don't implement anything else that this thing doesn't need. So, it is possible to make it as simple as it is possible to make it as simple as possible. I don't know if that's a correct sentence, but you got to be smart and strategic about it, and you got to plan, because before you know it, if you don't plan properly, you're going to have a ton of tech debt in 6 months, and you're going to be like, uh-oh, I gotta re-architect this entire thing. And that's never pretty either.
Let's talk about the tech debt. Is Kubernetes, will it ultimately be cost effective for me? And what are some of those cost efficiency things that I should look out for in order to implement this correctly?
Yeah, I don't know. I
love that honestness. Man, I don't know, but it's pretty cool to install.
So like, here's the thing. Like, let's say you got 10 VMs. and you're running a bunch of binaries and this and that, and then you convert them all to container, or not convert, it's not the right word, but you start to utilize containerization. But now you're running this managed Kubernetes service in the cloud, and you got 3, 4, 5 worker nodes, and these things are scaling out and this and that. So like, are you saving money by just moving to Kubernetes and being like, yep, we're done? I think it's less, well, yeah, it's a good question. Like I've never really compared the two. I think from a financial perspective, you're going to save money because of certain things, like, well, just moving into the cloud in general. Like, you don't have a data center, you don't have 20 people that you've hired to manage this data center, et cetera. Now you're kind of offloading this thing to the cloud. But like, I think that's as far as it goes from a cost perspective. Really, where you're saving money in Kubernetes is understanding the fact that, like, for example, you don't have to have somebody, setting up auto scaling. You don't have to have somebody, on call. Oh, this application went down at 2 a.m. I have to go fix it. Like, Kubernetes is, and the scheduler and all that, like, that's really supposed, and the self-healing, that's really supposed to take care of all of that for you. The whole idea is to confirm that your current state is your desired state. If it's not, please do something about it. If something needs to scale at 2 a.m., Kubernetes should be able to handle that for you. If there are 4 pods and there's supposed to be 5 pods, Kubernetes should automatically be going and doing that for you. You shouldn't have to wake up at 2 a.m. to kick up the pod replicas. So it doesn't save you money, but it realistically should be saving you time. Now, does
Does
it
the
always do
cloud
that?
already do that?
Yeah. Well, I mean, theoretically. Yeah.
Well, it's supposed to.
Yeah. Yeah. And I think that's the thing about, like, when you think about the cloud, like, let's say you're just running, workloads and VMs, and then you're running workloads in Kubernetes. Like, at the end of the day, they're all, from a technical perspective, it's all doing the same thing. It's really just the understanding what the next thing is. Like, running containers, because of the small form factor versus running an entire virtual machine, that's a big difference from, a size perspective, from that type of cost perspective. Running a container versus having an entire VM running for an application, that's a significant cost difference. Just like buying 10 servers when realistically you only need to buy 3 because you can just pop ESXi on them. That's a significant cost benefit. But from a technical perspective, it's all doing the same thing. It's just doing it at a different layer. That's all.
Okay, so besides cost, right? So let's take cost out of it. What's my
Mhm.
compelling reason as an enterprise to choose Kubernetes or cloud?
Yep. Yeah. So I think it's just the smaller form factor piece. So when you're thinking about, like, how everything kind of goes, we started out at mainframes. These things were refrigerator size or bigger. We needed a smaller form factor, but same power. So then we went to servers, much smaller, same power, more power. Then we said, okay, this is pretty big. We need another smaller form factor. So then we went to virtual machines, same power, applications run the same. We utilize servers very differently now, but they're more powerful or at the same power level. Then we went to containers, and it was like, okay, way smaller than a VM, smaller footprint, way less to manage, smaller form factor, applications still perform the same way. Where Kubernetes comes into play is, okay, great, this container is a smaller form factor, it costs us way less, it's way easier to manage, etc. But we need a way to run it at scale. That's where an orchestration platform comes into play, like Kubernetes, like Nomad, like Swarm. So it's not really it's actually the debate should more be not what Kubernetes does versus the cloud. It should be what VMs do in the cloud versus what containers do. That's the real debate. Kubernetes is just like the thing that manages your containers, but the meat of it all is what's running inside of your pod, which is your application containers.
The thing that manages your containers, like AWS, is the thing that manages your virtual servers.
Exactly. Yeah. And guess what? There's all like I had a client last year that Kubernetes was a huge thing for them and a huge lift, and they decided to go with AWS ECS. ECS is doing the same thing. It's just managing your containers. Same thing as Kubernetes, managing your containers. But going back to our conversation before, it's not that Kubernetes is doing something drastically different than all these other orchestrators. It's that this is the thing that the the Kubernetes is the thing that everybody chose to be the thing to use right now. Just like
Until the next thing comes along.
exactly, yeah, like and I always think about it like that. Like it is not that Kubernetes is doing something for us way different from a technical perspective than what the ECS does, than what Nomad does, than what Crossplane does, than what Swarm did, Mesos. All of these things are doing the same thing. Kubernetes is just what was chosen. And if you look back over the years, same thing again, like we were talking about with virtualization. You had ESXi, you had Hyper-V, you had I always forget Linux's version of virtualization. It's still used and stuff, but oh man, I forget what it was called.
I don't even recall for it. I know, I mean, actually, Hyper-V, I played around with it. Never thought it was
Yeah,
a production type ready thing. Always
right.
had issues
Yeah.
going on. But
Yeah, but they have Linux has their own that you can use. I'm forgetting this off the top of my head.
that's all right. You keep
Anyways,
going. I'm going to Google it.
yeah, yeah. Anyways, it's not that any of these platforms like did anything different. They all did the same stuff. They all did the virtualization, but VMware was chosen. It was the thing that was chosen. So
It's not distro or VirtualBox, is it?
no, not VirtualBox. I forget. Yeah, but
Uh, I know.
yeah, I forget.
Well, there's the KVM.
KVM. Thank you. That's what
Hey,
it
good.
is. KVM.
Thank Google.
Thank Google. Wow. Yes, KVM. So there are all of these like these different platforms, and they're not doing they're not doing anything different. The only thing is VMware was chosen. That's it. That's the only difference. So, underneath the hood, it's all the same thing. And the same thing with Kubernetes. Kubernetes is doing the same thing that all these other orchestrators are doing at the technical level of scheduling workloads. It's just what was chosen. And that's where I kind of come in from, a training and a consulting perspective. My thing as an independent consultant and as a trainer and as a content creator, I'm not creating stuff that's the latest and greatest. I'm not pushing products on you. I'm teaching you what's being used in production right now. And from a production perspective of what's continuously growing, Kubernetes is being utilized. That's why, when you look at my content and when you look at my consulting and my training and stuff, I'm not just like pushing stuff out that I think is cool. Very rarely am I creating a piece of content that's like, oh, this thing is cool and this is super popular and I'm going to get a lot of views and yada, yada. I don't care. What I care about is creating the stuff that's going to help people use in production. What's being used in production right now, realistically, okay, let me create content on that. Let me create training on that because that's what's actually going to help engineers with their job. All of this other, flashy stuff, this isn't like what's helping them with their job right now. So that's why I focus very much on answering the questions in the way that I answer them with not that the difference between Kubernetes and cloud. Kubernetes is doing the same thing as everything else. It's just what's the new thing or what's the thing right now. And that thing is Kubernetes.
Actually, that leads me to my next question, and I have one more after that. Is some of the training and technical content that you create, what are some of the skills that are needed? Because going into cloud, you need cloud skills. So that's another one I got to invest in. And now we want to go to Kubernetes, and now I have to invest in Kubernetes and Kubernetes on cloud. And it's a lot to understand for one person to take this on in a short amount of time. What are the skills that are needed in order to run an efficient Kubernetes environment?
Yeah, so I would say you should have a solid understanding of infrastructure and systems administration, and you should also have a decent enough understanding of programming and development because you're going to see it on both angles. So, like, for example, you can't run a production level Kubernetes environment unless you understand networking. I don't care what anybody says, you can't do it because even though, let's say even you're running in like a managed Kubernetes service, AKS, EKS, GKey, whatever, you're still managing everything at the network level, not only at the host network level, but at the pod network level. You're still managing firewall rules. You're still managing these network policies. You're still managing ingress and egress. You're still managing what pod can talk to what service can talk to what. You're still managing all of this stuff, ports, everything. If your code inside of your application is saying, I need to listen on 8080, port 8080 needs to be open. And then the question is, where does that need to be open? Who else needs to talk to port 8080? What ingress points need to talk to 8080? So it's like there are all these things from a networking perspective. So networking, you definitely need to know. You definitely need to understand general systems administration of operating systems. You need to definitely understand scalability, how it all works, etc. And then from a development perspective, you're running applications, you're running application stacks. You need to understand how to troubleshoot applications. You need to understand how applications scale. You don't need to know how to build the next Twitter or Instagram, but you do need to understand, general programming.
I think I'm going to leave everybody with this, is that if you're going to work with cloud or Kubernetes, I think the basic understanding is some of my core training came from building an actual server. I worked for an internet hosting company. We built servers, we racked and stacked them. I installed the OS, troubleshooted connectivity, put in some routes. And yes, I was at the DOS prompt, putting in route tables and adding all the, and I think understanding that and firewall rules is actually key to anything you do within a cloud environment. Yes, you're not touching it physically, but you get to understand and troubleshoot how things work and connect. And I think that's key for understanding that. And I actually just came up with a business idea. I'm not going to drop it here because nobody's taking it. This is what happens when like minds go together. Yeah. Michael, I'm going to leave everybody with this. How can people get a hold of you? Where can they connect with you and look for more of your content?
Yeah, so the best place right now is LinkedIn. So feel free to follow me over there, Michael Levan. I also have Twitter, but I'm a little bit less active on Twitter than I am on LinkedIn. And I also have a link tree that I'll send you, John, that you can put in the show notes. That way, that's like, because I just do so much stuff and I'm so all over the place that the link tree just kind of points you to wherever you need to go. But yeah, LinkedIn, Linktree, michaellevan.net. Those are the three best places.
Michael, I heard you got a cool website.
Yeah, exactly. Yeah. Thanks to Myer Media for a lot of really cool landing pages.
Michael, you're awesome. Michael, thank you so much for joining me. I really appreciate it and helping us understand Kubernetes.
Sure. Thank you so much, John. Appreciate you having me on.
All right, everybody. Michael Levan, consultant, trainer, and content creator. Our topic today was Kubernetes, virtualization of the virtualization and data center layer, the cost, the efficiency, the skills, and everything that it takes to move from development to production. And no, we didn't break it down in step by step, but Michael can help you with that because he has in-depth knowledge and he's not a self-proclaimed expert, but in my opinion, he's close enough for it. Everybody, this has been the John Myer podcast. Don't forget to hit that like, subscribe, and notify because guess what? We're out of here.